Good evening, everyone. A very good evening, everyone. Great. Welcome back to our day 4 of our FDP, SDP, STTP on Python for AI 2025. So we have successfully completed 3 days of our training. Great. So we'll quickly recap what we have covered in the last days and then we'll start a new topic today. Right. So far what we have understood? We understood what exactly is Python. Right. How the name was a programming language was named as a snake name. We understood the history of Python. Then we understood the features, the important features of Python. And we started with the core concepts, the fundamental concepts like variables and data types. Am I right? So what are variables? Variables are nothing but objects in Python which help us to store values, which help us to store literals, represent the literal values. So these variables are nothing but keywords, identifiers. So in order to define these variables, we have some ground rules. We understood all the rules one by one. And we have also completed our hands-on. Next to variables, we understood data types. We understood the concept of data types. The purpose of data types, and within Python, we have 14 data types, which are categorized into 6 categories. There are 6 categories. What are they? Fundamental category, sequence category, list category, set category, dict category, and non-type category. So these 6 categories together contain all the 14 data types in Python. So let us quickly recap whatever we have covered this as part of data types. Then we'll start with operators in Python. Okay. So I want everyone to respond here. I'll be asking you questions. It's better if you respond so that I'll come to know. Right? So whether you are following or not, please respond in the chat. So let me start with fundamental category. What is the purpose of fundamental category data types? What is the purpose of fundamental category data types? Everyone. In order to store single values, we use fundamental category data types. To store a single value, we use fundamental category data types. Good. Tell me the different types of data types that we have in the fundamental category. Store single value, we use fundamental category data types. Good. What are the different data types that we have under fundamental category? We have int, then float, bool, and complex. Right? So these are the different data types that we have in fundamental category data types. Perfect. What is the purpose of int type? What is the purpose of int data type in fundamental category? To store integer values. If I want to store integer values, we use int data type. Perfect. Float data type. In order to store decimal values. Okay, within a number, if we have decimal values, floating numbers, we go with float data type. Then bool data type, bool. To store logical values, what are they? True, false. So that means not to store these Boolean values, true or false, we go with bool data type. Bool data type is used. Internally, true is referred as 1 and false is referred as 0. Then finally, we have discussed complex data type under fundamental category. Okay, so which is actually helping us to store complex numbers, which are in the format of a plus bj and a minus bj. Right? Yes. So these are the different data types that are part of fundamental category. Let me go to the second one. What is the second category? Sequence. What is the purpose of sequence category? It helps us to store, a sequence of values. Sequence of values or elements, whatever it might be. What are the different data types that we have under sequence category? STR, bytes, byte array, and range. So these are the different data types that we have under sequence category data types. Under sequence category data types. Yes. So what is the purpose of STR data type? Under sequence category, what is the purpose of STR data type? STR type help us to store sequence of characters enclosed in single quotations or double quotations or triple single or triple double. Right? Yes. Bytes. Purpose of bytes data type. Purpose of bytes data type is they help us to store positive numbers, positive integers from 0 to 255. Bytes is a immutable data type. It is an immutable data type, which means it does not support item assignment, guys. Item assignment is not supported by bytes. But can we perform slicing and indexing? Yes, we can perform indexing and slicing operations on bytes object. Then next to bytes, we discussed byte array. We discussed byte array data type. So what is the purpose of byte array data type? It is similar to bytes. Byte array is similar to bytes. But what makes the difference between byte array and bytes is an immutable type, whereas byte array is a mutable type. Okay, we can change even after creating the object. It helps us to edit. Right? Next to byte array, we discussed range. We discussed range type. So what is the purpose of range type? Range type also help us to store positive integers. Okay. But with the interval specified the step. Range is a immutable type. So it does not support item assignment. So you have to memorize all these topics. No, whatever the points that we are discussing now, they are very important. Then next to sequence, in the last session, we started with the list. List category data type. Tell me the purpose of list category data type. A list category data type, they help us to store multiple values. multiple values can be stored using list category data types, in which these values can be of same type or different type, and these value can be unique or duplicates as well. You can also have duplicates, right? Then what are the different data types that we have under list category? List and tuple. List and tuple. So what makes the difference between list and tuple? The purpose of list and tuple is same. Help us to store multiple values of either same type or different type, and these values can be unique or duplicate. But the difference between list and tuple is the elements of a list are enclosed. They are organized in square braces, whereas in a tuple, the elements are organized in a regular braces. These are called parentheses. List is a mutable object, whereas tuple is a immutable object. Does not support item assignment. Can we perform indexing and slicing? Yes. Indexing and slicing can be performed on both the types, list and tuple. Then next to list category, we discussed set category data types. So what is the purpose of set category data types, guys? Purpose of set category data types. Guys, you have to respond. Right? What is the purpose of set category? Set category data types help us to store again multiple values. So these values can be of same type or different type, but these values will be they must be only unique. Duplicates are not allowed under set category data types. Okay. Then what are the different data types that we have under set category? We have set and frozen set. Set and frozen set. So can you tell me the difference between set and frozen set? Set is mutable and immutable object, mutable and immutable type, whereas frozen set is it is a immutable data type. When is set mutable type and when is set considered as immutable type? Come on. Set is mutable in case of add function, and set is considered as an immutable type in case of item assignment. So that is the difference. Okay. Then coming to frozen set, every time, it is both in case of add function and item assignment, frozen set is identified as immutable type only, guys. In case of both add function and item assignment, frozen set is considered as immutable type. It doesn't change. Once if the frozen set object got created, it doesn't change, fixed. Then indexing and slicing operations can we perform on set and frozen set? No. Why? They do not maintain the insertion order. Set data types and frozen set data type, they don't maintain the insertion order. If the insertion order is not maintained, how can we perform indexing and slicing? Impossible. Right? So these are the different points that we have discussed regarding set category data types, and we also discussed dict category, in which we have only one type, that is dict. Under dict category, we have only one data type. It is called dict. So what is the purpose of dict data type? The purpose of dict data type is, it helps us to store the data in the form of key value pairs. In the form of key value pairs. So within a dict object, you will have the data being stored in the form of key value pair, where key and the value will be separated by colon and the key value pairs will be separated by comma. So this is important. And out of keys and values, which of these are mutable and which of them are immutable? Mutable are values, immutable are keys. Right? And the values, we can have the duplicates, but for keys, they should be unique. We cannot have duplicates for keys. Right? So this is what we have discussed in the last class. And today we are going to start with a new topic. It is operators in Python. The next topic we have is operators in Python. So the agenda for the day will be understanding the different operators, okay, the purpose of operators and the different types of operators. And we'll also focus on the hands-on part. After completing operators, we'll also focus on conditional statements. Okay, so we'll understand each and every conditional statement and we'll try to close it off. Right. Yes. So what do you mean by operators, guys, in Python? If you have any basic idea, please reply to my question. What is the purpose of operators? Any idea? Any knowledge on operators? Okay, that's fine. What exactly is an operator? Operator represents a symbol. Operator represents a symbol. Okay. And what is the purpose of these operators? They help us to perform operations. Using operators, we are able to do operations. Okay. Then, if two or more than two variables, okay, two or more than two variables, they are connected with an operator, then it is called expression. It is called expression. So let us understand. When we move further, you'll understand what exactly is expression. In Python, there are in total 7 types of operators. What are they? Arithmetic operator, assignment operator, a relational operator, logical operator, membership operators, identity operators, and bitwise operators. Okay, so this is what you have to observe. In total, there are 7 different types of operators in Python. What are they? I repeat, arithmetic, assignment, relational, logical, membership, identity, and bitwise. So let us understand one by one, and we'll also focus on the hands-on for each and every type of operator. Okay. And in Python, we don't have there are no operators like plus, plus, minus, minus, and ternary operators. They're not supported. Okay. So let us start with arithmetic operators. The first type of operators that we have is arithmetic operator. For this, I'll directly jump into the hands-on part because we have the information for arithmetic operators over here. So what exactly is the purpose of arithmetic operator? The purpose of arithmetic operator is to perform arithmetic operations. Okay. So if you see here, under arithmetic operator, we have plus, minus, star, asterisk mark, then backward slash, double slash, this is percentage, and the next one is double star. We'll understand what exactly these, symbols represent. We'll understand one by one. All these 7 are nothing but the arithmetic operators in Python. And why do we use them? What is the benefit of learning it is they help us to do some operations. When I use plus, I can perform addition operation. Now you're getting the point, guys? What is the purpose of operators? They help us to do some operations. Okay. So operators are nothing but some symbols. These symbols help us to do some operations. Certain operations can be performed. Addition, subtraction, multiplication, division, floor division, modulo, and finally exponent. So these are the different arithmetic operators that we have. So I'll take an example. Let us understand all the arithmetic operators one by one. See. What am I doing in line number 1044? 1044. I am storing 10 in a variable, in an object A. So will this execute? Yes, it will execute because we are following the ground rules. So obviously 10 gets stored in A. See? Done. In the same way, I am storing 3 in B. Will it execute? Yes, this will also execute. So 3 gets stored in B. Now, tell me what will be the output for line number 1047? What am I doing? I'm using print function, but within the print function, we have an expression. What is this expression called? Arithmetic expression. Why it is called arithmetic expression? Because two variables A and B are connected using what? They are connected using a arithmetic operator. That is why it is called as arithmetic expression. I hope it is clear. Right, this is called an arithmetic expression and the output for line number 1047 will be 10 plus 3. Good. 13 will be written as output. 13 will be written as output. And I want the output for line number 1049. 1049. A minus B. A minus B, guys. What will be the output? 10 minus 3. So the output will be 7. Good. Then, next line, 1051. Everyone have to respond. Don't sit idle. Nothing you are going to gain. If you sit silent, nothing will be gained. Respond. Output for line number 1051. What am I doing? A multiplied by B. This star represents, asterisk mark represents, multiplication operator. So 10 multiplied by 3, output will be 30. Good. Output will be 30. Line number 1053. What are we doing? We are using division operator. A division operator will return coefficient, guys. A division operator returns coefficient. So what exactly happens is we are dividing 10 by 3, which is representing as the division. So this part is called quotient. The quotient gets returned by a division operator. Exactly. You'll get 3.333 so on, right? So as we know, 10 is not exactly divided by 3. We'll get the output in decimals. Good. And always remember, our division operator will return a float as output. Always remember, a division operator returns a float value as output. Even though if it is perfectly divisible also, it will return as a float value as output. Then the next line, 1055. So what does this operator means? We know single slash represents division. But what about double slash? This represents floor division. So that means even floor division also performs division, but only the floor value will be returned, guys. Only the floor value will be returned. So what will be the output in case of line number 1055? Yes, it will be 3. It will be 3. Excuse me. Then the next line, 1057. I am using modulo operator. Modulo operator is represented with percentage symbol. Okay. So when I say A percentage B, modulo operator will return as the remainder. It returns the remainder. So what will be the output for line number 1057? 10 modulus operator divided by, 3. The output will be what will be the output, guys? 1. We know that 3 3s are 10. So obviously the output will be 1. 10 minus 9 will be 1. Good. And the last operator that we have under arithmetic operators is exponent or power. It is power. So how do you represent it? We represent power operator with a double asterisk mark. A single one is multiplication operator. Double represents power operator. So this is nothing but A power B. What is A? 10. What is B? 3. So that means 10 raised to the power 3. What will be the output? The output will be 1000. Output will be 1000. Okay. So with this, we have successfully completed our arithmetic operators. We have completed the arithmetic operators. Now let me go to the assignment operator. The next operators that we have are assignment operator. So without noticing, from day one, we started using assignment operator. Did you observe it? See, when you are defining a variable, when you are declaring a variable, you are following the ground rules? Yes. Say I have a variable like this, A. But you should also have the literal, right? Fine. Say assume that I want to store 5 in A. accepted. 5 is your integer literal and a represents your variable, fine. But what is equals to? Is equals to is nothing but assignment operator. Is equals to is nothing but assignment operator. What is the purpose of assignment operator? The purpose of assignment operator is to transfer whatever the value that you have on the right hand side. Okay, the value that will be transferred from the right hand side to the left hand variable. To the left hand side variable. So that is the purpose of assignment operator. You are assigning the value. And within the assignment operator, we can use it in two ways. One is single line assignment and the other one is multi-line assignment. So let us understand both these different types, the two methods of using assignment operator. So initially, let me focus on the single line assignment. You see the syntax? What does the syntax say? Variable name is equals to value. That's it. So that means here is an example. You are assigning a single value to a single variable. Done. Or an expression to a variable. Done. That becomes single line assignment. Okay. So here is the examples already. From day one, we are performing single line assignment only. So we already have few more examples. Let me focus on them. Observe line number 1074. A is equals to 10. A is equals to 10. So I am going to store 10 in A. I am assigning 10 to A. So this is a single line assignment. Done. In the same way, I am going to store 20 in B. Right. So this is also an example of single line assignment. Next to it, what am I doing? I have an arithmetic expression. So this expression, I want it to get transferred the output to the left hand side variable C. So what is A plus B? A plus B will return as 10 plus 20. 30 will be written as output. So this 30 will be assigned to C. Observe. And then finally I'm going to print all these variables A, B, C together using print function. 10, 20 and 30 are the outputs. So these are the examples. So this is an example of single line assignment, guys. So this is an example of single line assignment. What is multi-line assignment? Multi-line assignment is, assigning multiple RHS values, multiple right hand side values will be assigned to multiple left hand side variables. C. Variable 1 will be, value 1 will be assigned to variable 1. Value 2 will be assigned to variable 2. Value n will be assigned to variable n. So on. So this is called multi-line assignment. Within a single line, we are going to assign multiple values. Making sense? Yes. So here is an example of multi-line assignment. A comma B comma C is equals to 10 comma 20 comma 30. 10 comma 20 comma 30. So what is happening here? 10 gets assigned to A. 20 gets assigned to B. 30 gets assigned to C. Within a single line, are we able to perform multiple assignments? Yes. So this is an example of multi-line assignment. Example of multi-line assignment. So let me execute line number 1084. Yes. So the values for A, B, and C, they got assigned. And when I say print of A, comma, B, comma, C, this will return me, 10, 20, and 30. 10, 20, and 30 will be returned as output. Fine. What will be the output for line number 1087? A plus B plus C. What is value for A? 10. For B, 20. For C, it is 30. So when I add all these values, I'll get the output as 60. So this 60 will be assigned to D. This is again a single line assignment, guys. See. Then let me come up with one more example for multi-line assignment. Observe line number 1090. What are we doing? A comma B is equals to 10 comma 3. So that means 10 gets assigned to A and 3 gets assigned to B. So let me do it. Yes, done. You see the values got updated? Yes, that means multi-line assignment was done. Then next to it, what am I doing? I am using again multi-line assignment only, in which the addition of A and B will be assigned to R1, subtraction of A and B will be assigned to R2, multiplication of A and B will be assigned to R3, and finally the power of A and B will be assigned to R4. A power B will be assigned to R4. So this is again a multi-line assignment. Observe carefully. Within a single line, the 4 values got assigned. Are the results correct? A plus B is 13. A minus B is 7. A multiplied by B is 30. And A power B is 1000. Done. Done. Then when I say print of A comma B, the values will be same, 10 comma 3. Okay, the values are same, 10 and 3. But what are the values for R1, R2, R3 and R4? They are 13, 7, 30 and 1000. 30 and 1000. So this is all about assignment operator. In Python, we have only one assignment operator. It is nothing but is equals to. It is nothing but is equals to. Then next to assignment operator, we have relational operators. Even relational operators are also not new for us. You know why? Because these operators we are learning from our school days. Greater than, less than. Greater than equals to, less than equals to. Equals to, not equals to. So are these new for us? No. We have already learned as part of our school days. I hope you remember them. But anyways, we have to recap, right? As part of relational operators. What is the purpose of relational operators? They help us to compare the values. They help us to compare the values. So when two or more variables, if they are connected with a relational operator, it becomes a relational expression. Similar to arithmetic expression, if the variables are connected with relational operator, it becomes a relational expression. And relational expression always returns only true and false. A relational operator will return us only true or false. Apart from true or false, you will not get any other output base. There is no third output in case of relational operators. Only two. Either true or false. That's it. Right. So let us start the hands-on. For that, what I'm doing is, I'm taking three variables. A is equals to 10. So storing 10 in A, then storing 20 in B, and finally again storing 10 in C. Done. This is done. Now, let me start using the relational operators one by one. What is the first one that I'm using here? Line number 1107. What am I using? Greater than. Greater than operator, guys. Okay. When does greater than operator return true? When the value of A is greater than B, then obviously greater than operator returns true. What if the value of A is less than B? Then it returns false. Right? So I'm talking about line number 1107. Okay. So what is the value that we have in A? It is 10. What is the value that we have in B? 20. Is 10 greater than 20? No. 10 is less than 20, right? So here our operator greater than will return as false. It returns false. In the same way, the next line, let me use less than operator. So tell me the output for line number 1109. 1109. B less than C. What is the value that we have in B? 20. C, it is 10. Is 20 less than 10? No. Even here also it will return as false. 20 is greater than 10, friends. Fine. In the next line, 1111, the operator that we are using is called is equals to. In Python, double is equals to is called is equals to operator. What is single is equals to called? Assignment operator. This is assignment. This is equals to. Don't get confused. Okay? Right. So what am I doing? I am saying that A is equals to C. A and C, the values both are same? Yes. So 10 equals to 10. It is matching. So obviously the output will be true. The output for this line will be true. Good. And the next line, A not equals to C. This is called is equals to, and when I represent exclamatory mark with is equals to, it is called not equals to operator in Python. It is called not equals to operator in Python. So what am I doing? I'm saying that A is not is equals to C. So 10 not equals to 10. It is false. The output will be false. Good. In the next line, what am I doing? A greater than or equals to B. I kept it as A greater than or equals to B. Is A greater than or equals to B? No. 10 is not greater than or equals to 20. So the output will be false. Tell me the output for line number 1117. 1117. What is the expression that we are using here? This is called a relational expression because I'm using a relational operator between two variables, right? So A less than or equals to C. Sorry, B less than or equals to C. Is B less than or equals to C? No, this is also false. False. Simple, guys. See, The purpose of relational operator is to compare the values. Okay. So the comparison can be done using the symbols. Which symbols? Greater than, less than, is equals to, not is equals to, greater than equals to, or less than equals to. So these are the 6 operators that we have under relational operators. Under relational operators, we have 6. And remember this, every time relational operators will return us only true or false. If the condition is met, it returns true. If the condition is false, it returns false. Clear? Let us go to the next operators. They are logical operators. What are they? Logical operators. So what is the purpose of this logical operator? Let us understand. Right. So the purpose of a logical operator is they help us to combine two relational expressions. Okay. If you have two or more than two relational expressions, and if you want to combine them, you can go and use a logical operator. What are the different logical operators that we have in Python? We have OR operator, OR logical operator, then AND logical operator, and NOT logical operator. So these are the different types of logical operators that we have in Python. And always again remember this, a logical operators in Python will return again true or false only. They return either true or false. That's it. Apart from these, no. Will not have any other output, guys. I hope you understood the purpose of logical operators. What is the purpose of logical operator? They help us to combine two or more than two relational expressions. What does that mean? When do you say relational expression? When we have two variables which are connected with a relational operator, then it is called a relational expression. Then it is called a relational expression. So let us work out on the logical operators one by one. The first operator that we are trying to understand is OR operator. For the logical operators, you'll observe the truth tables. You'll observe the truth tables. So let us understand the truth table for OR operator or logical operator. So for sure you'll have at least two relational expressions. Yes, expression 1, expression 2. If the expression 1 is true and if the expression 2 is false, what will be the output when I use OR between these two expressions? The output will be true. The output will be true. What if they are reversed? Expression 1 is false, expression 2 is true. Still the output will be true, guys. Okay. What if both the expressions are true? Even there also the output will be true. Even in that case, the output will be true. Okay. What if both of them are false? Only if both the expressions are false, a logical OR operator returns false. In rest of all the cases, it returns true only. When does logical OR operator return false? Only if both the expressions return false, they are not satisfying the condition. Then logical OR operator will return false. Whereas in rest of all the cases, it returns true. Okay? Right. So here are a few examples. If you memorize this truth table, you can solve any example, guys. See. I'll give you enough amount of time. I want the output for line number 1141. In 1141, there are two relational expressions. What are they? This is one relational expression. This is the other one. And how did these two relational expressions get connected? They got combined using logical OR operator. Using logical OR operator. So tell me, what will be the output for line number 1141? Will it be false or true? Think. Is this condition matching? I mean, is it satisfying? This is false. Why? 10 is not greater than 20. No. What about this one? Even 20 is not greater than 30. So both the conditions are false. So when both the both the expressions return false, the output will also be false. Good. Good guys. Keep it up. In the same way, respond for line number 1143. 1143. Anyways, we know it the same. 10 less than 10 greater than 20. This is false. Or 20 greater than 20 is less than 30. This is true. 20 is less than 30, right? So one condition, one expression being false, the other expression being true. What will be the output? The final output will be true. Here the final output will be false. So now I'll cross check by executing these lines one by one. So for the first case, I have to get false as output. Yes. It returned me false as output. In the same way, let me also do it for the second example. It returned me true. Is it clear? Is it clear or not? Very simple. See, if you understand and memorize the truth tables, you can answer any question. In the same way, let me explain you. Okay, there is one more example. Answer the next one. What will be the output for line number 1145? The output will be yes. See, here is 10 minus 10 less than 10. Yes, true. 100 greater than 200, false. So one true, one false. The output should be true. Good. Keep it up. In the same way, let us also understand the next logical operator in the sequence. It is AND operator. It is AND operator. So what does this AND operator return? AND operator, like how we have a truth table for OR operator, in the same way we also have AND operator. Okay. So when does AND operator return true? Only if both the expressions return true, AND operator returns true. What about the rest of the cases? It returns false. It returns false. So if you observe, in case of R, only if both the expressions return false, OR operator return false. But here, only if both the expressions return true, AND operator returns true. That is the main difference between OR and AND operators. Right? So let us quickly have a look on a few examples. I want you guys to answer for line number 1161. 1161. 10 greater than 5? Yes, this is true. 20 greater than 6? Yeah, this is also true. So both the expressions returning true, the output will be true. The output will be true. In the same way, respond for line number 1163. 10 less than 5, false. 20 greater than 6, true. 1 false, 1 true. Output will be false. Because I am using AND operator. Observe carefully. I am using AND operator. Clear? Then 10 greater than 2, this is true. And 20 greater than 6. So this is also true. So when I use AND operator between these two, I'll get true as output. For this entire thing, I'll get true as output. Then next to it, we have OR operator in the picture. 20 not equals to 10. This is also true. So between true and true, if both the expressions return true, OR operator, we know that it will return true as output. And 20 is equals to 20. This is also true. So since I'm using OR operator, the output will be true again. So what will be the overall output for line number 1165? It will be true. Let me execute. So that is how you have to evaluate the given expressions. Okay, it can contain multiple expressions. Not every time you need not expect only two. You can also get multiple. Right. We understood OR operator and AND operator under logical operators. Now let us understand NOT operator. So what is the purpose of NOT operator is, it helps us to reverse the output. It helps us to return the opposite of the value. How? Is, if your expression says true, when I apply NOT of the expression, the output will be false. If the expression returns false, if I use NOT of the expression, the output will be true. So in this way, in short, I can say that NOT operator returns the negation of your results. Negation. Right? So let me work out on a few examples. What am I doing here? Storing 100 in A. Yes, 100 gets assigned to A. Done. The same way, 20 gets assigned, 200 gets assigned to B. Now, I say A greater than B. Is it true or false? We know 100 is not greater than 200. The output will be false. Output is false. But what if I apply NOT operator? What if I apply NOT operator on A greater than B? If I apply NOT of A greater than B, the output will be reversed and I'll get the output as true. False will be reversed and I'll get true as output. Right? And finally, answer line number 1186. I want everyone to answer 1186. What will be the output? 10 not equals to 5. Yes, true. 10 not equals to 10. This is false. Since I am using OR operator, one is true, one is false. So obviously the output will be true. But when I say not of true, the output will be false. The output will be false. Good. Be active, guys. If you be calm, there is no use. There is no use of this program, right? You have to respond to my questions. Right? So the next operators that we have are membership operators. So I'll go back and let us understand what is the purpose of membership operators and What are the different types of membership operators we have in Python? What is the purpose of membership operators? Membership operators, they help us to check. They help us to check or verify, okay, the existence of the specified value. What you are checking, what you are verifying is, you are verifying the existing of a value in iterable object. What is an iterable object? Iterable object is an object which contains many values, multiple values. That is called iterable object. Some examples. List is an iterable object. Sequence category types, the objects. str type, bytes, byte array, all of these are iterable objects only because they can hold multiple values inside it. I hope it is clear. So, the purpose of membership operator is to verify the existence of the specified value in iterable object. If it is present, you'll get one answer. If it is not present, you'll get the other answer. Right? So in Python, we have two types of membership operators. What are they? One is in and the other one is not in. One is in operator and the other one is not in operator. So what is the syntax for in operator? The syntax for in operator is value in iterable object. Okay, whatever the specified value that you are checking, that value in iterable object will be the syntax for in operator. For not in, value not in iterable object. Simple. Okay, so let me talk about in operator. In operator returns true when value is in this iterable object. When the specified value is in the iterable object, in operator returns true. What if this value is not present in this iterable object? In operator returns false. Not in works quite opposite to in. Not in works quite opposite to in. When does not in returns true? Not in operator returns true when the value is not in the iterable object. When the value is not present inside the iterable object. Okay. What if the value is present in the iterable object? Not in returns false. Not in returns false. Simple. So let me explain, in and not in with examples. Because conceptually it is very clear. Because the purpose is very crisp. And it is very clear, right? So now let us talk about a few examples related to in and not in. What am I doing, guys? In line number 1190, 1190. I am storing Python in S. Right? str type will be used to store Python because the Python is enclosed in double quotations. So we are storing a sequence of characters enclosed in double quotations. Obviously, str type will be used. Fine. Next to it, I'm coming up with membership operator in. Membership operator in, I'm using it and I have specified as P in S. P is my value. In represents membership operator. What is S representing? S represents a iterable object. S represents an iterable object. So do we have P in S? Do we have P in S? Yes, I see P in Python. So obviously, the output will be true. The output will be true. Okay. Next line. P in S. Will it be true again? No. This time it will be false. Why? If you observe properly, the P that I am going to check is lowercase p. It is lowercase p. So do we have lowercase p in Python which is in uppercase? No. So this will return me false. When it is checking, ensure that the proper keys. It also checks for the keys. Then answer for line number 1193. 1193. NEUT in S. NEUT in S. So do we have NEUT in Python? No. There is no NEUT in Python. Obviously, the output will be false. HON in Python. HON in S. Do you see HON? Yes. Same case? Yes. So the output will be true. Output will be true. Then PTN in S. Do you see PTN? I see PTN, but they're not. No. In the same order that like we have specified. So obviously then it will return false. Obviously it will return false. Can you tell me the output for line number 1196? NOH in S of colon -1. Will this be true or false? This will be true. Why? You are printing this str type object in the reverse direction. So when you do it in the reverse direction, it will start from here. NOHTYP will be printed. That is what it means. Okay. So I see NOH. NOH is there. The output will be true. Good. Then next to it, I'm coming up with a list object with 4 elements, 4 values. So what will be the output for line number 1199? 1199. Will this be true? Yes. 10 in LST. Yeah, I see 10 in LST. In the list object, there is 10. True. Rosum not in LST. Do we have Rosum or not? Yes, we have Rosum. Our father of Python is present in the list object. So when you say Rosum not in LST, this will return me false because we have him. We have Rosum in our list object. Then next to it, what am I doing, guys? What is this object called? It is a set object. Good. A set object of size 7. So when I say 100 in S1, what will be the output? What will be the output? False. There is no 100 in set object S1. 100 not in S1. Yes, this will be true because there is no 100. So in this way, the purpose of membership operators is to check the existence of a value in iterable object. And within Python, we have 2 membership operators. They are in and not in. They are in and not in. Right? So this also marks the end of membership operators. Now let us go and understand identity operators. Identity operators. So what is the purpose of identity operators in Python? What is the purpose of identity operators in Python? Is identity operators in Python help us to compare the memory address. They help us to compare the memory address of the objects. So within the main memory, the objects get stored. Yes. So we are going to compare the memory address of the two objects. And in Python, there are two different types of identity operators. What are they? Is and the other one is not. Is and is not are the two identity operators that we have in Python. So the syntax for is object 1 is object 2 or variable 1 is variable 2. So I'm using is operator if you observe. In the same way, is not. Object 1 is not object 2 or variable 1 is not variable 2. Okay. So in this way, you'll observe the syntaxes for identity operators. Let us understand how this is and is not operators work. Let me start with is operator. If you see here, is operator will return true. When does is operator return true? You know, when both these objects, object 1, object 2 or variable 1, variable 2, if they point to the same memory address, then is operator returns true. Okay. What if they point to different address? If they point to different memory address, it returns false. It returns false. In the same way, is not operator works quite opposite to is operator. Okay. So is not operator will return true when both these objects or variables, they pointing to different memory addresses. They point to different memory address, then is not operator returns true. What if they point to the same memory address? Is not will return false, guys. So this is how is and is not operators work in Python. But a few important points that you will be learning as per identity operators, they are very important. So I'll be taking each and every object and I'll be explaining you the examples. Okay. So let me start with the none type. But before that, let me clear up my memory once. Taking a lot of time, we are done. Right. So what do you see here? What do you see here, guys? I am defining a none type object. I am coming up with a none type object. Okay. So I'm storing none in A. So which will return me a none type object and I'm doing the same in B as well. Done. Done. Then what am I doing next to it? I'm going to get the results of A, the type of A and the address of A using ID function. Using ID function. So these are the results. In the same way, let me get the information from B, where I'm using print function to print all the information like B, type of B and ID of B. And what do you observe from it, guys? From the results. If you observe clearly, both A and B, are they pointing to the same memory address or different memory address? They point to the same memory address. You know why? Because in Python, we can have only one none. We can have only one none. They are singleton objects. Okay, these are singleton objects as both of these objects A and B are pointing to the same none. They have the same address. So when I use is operator, it returns true. When I use is not operator, it returns false. It returns false. So that is how is and is not operators work in Python. The identity operators is and is not work in this fashion. Can you tell me what will be the output for the next example? Where I am taking a dict object as example, dict type. Can you go for a guess? Come on, guys. See, what am I doing here? I'm coming up with a dict object with two key value pairs. I'm storing in D1. Done. In the same way, the same key value pairs I'm storing in D2. So what do you think? Does D1 and D2 will be stored at the same location? Do they point to the same memory address in the main memory? No. Even though if they have the same key value pairs, it creates two different objects. How do I confirm it? Cross-check the memory location. If you observe the memory location, there are two different values. So when I use is operator, it will return me false. When I use is not, here it will return me true. Here it will return true. Clear? Right. Next example is related to set. Next example is related to set type. Can you guess the output for this case? Set data type objects. Guys, everyone have to respond. What are we doing in line number 1222? We are coming up with a set object of size 5 and the same elements I'm also assigning to a set object S2. So two different set objects were being created. But the point here is, do they point to the same memory? No. To the same address in the memory or to the different address in the memory? What do you see? They point to different addresses in the memory. The reason being, S1 is a different object, S2 is a different object. Both are not same. So even if you can cross check it by ID function. See, did you get the same values? Same addresses for both the cases? No. So when I use is operator, it returns me false. And if I use is not, it returns me true. This will return me true. Obviously, different addresses, no? Is operator will return false, is not will return true. Right. Let us work on frozen set objects. On frozen set, we are done with the dict object. We are done with set object. Now let us come with frozen set. How can I build frozen set objects using frozen set function? Yes. So I'm taking S1, S2, which are set objects, and I'm converting them to frozen set. And I'm storing them to FS1 and FS2 respectively. See? So do they represent two different objects in the memory? Yes, they do represent two different objects in the memory. Sorry. They do represent different objects in the memory. So this is one object, FS1, and this is the other one. See, there are two different objects in the memory. When I use is operator, it will return me false. And if I use is not, it will return me true. The difference between, is and is not, I think you guys are observing it properly. Next to it, let us work on tuple objects. I'm coming up with the two tuple objects T1 and T2 where the elements are same, the values are same between T1 and T2. So let us check whether they will be created in the same location or different location. Do they point to the same location, guys? No. T1 and T2 are two different objects. They are two different objects in the memory. When I use is operator, it returns me false. If I use is not, it returns me true. This will return me true. Then next to it, list objects, list data type. Okay. So let us work on list objects. So what do you think? Will it create two different objects, both L1 and L2 in the memory? Yes, they do create two different objects in the memory. L1 will be a different object and L2 will be a different object. How can you clarify it? Using ID function. See, there are two different objects that will be created in the memory, in the main memory. Okay. When I say L1 is L2, it will return me false. And if I say L1 is not L2, it returns me true. What it is doing here, it is just comparing the address. If both of them are same, is operator will return true. If both of them are true, if both of them are same, is operator returns true. What if they are different? Is not will return true. Okay, that is the difference. Next to it, let me take a range object. Range of 0, 10 will return me what, guys? What numbers will be stored in range of 0, 10? Try. This is our start. This is our stop. Okay. So the values will be from 0 till 9. 0 till 9. So the same object I'm creating one more, and one object I'm assigning to R1, the other one I'm assigning to R2. So what do you think? Will they have same address in the memory? It will not be from 1 to 9, it will be from 0 to 9. Pay attention. What is the start value? 0, not 1. 0 to 9, 0 to 9. Okay. So both the objects have same elements, but still both of them will be stored at different locations. It will create two different objects. Two different objects will be created in the memory. So let me do it. Done. R1, R2 got created, and I'm printing the addresses of these two. If you observe, are these addresses same? No, they are not same. So when I use is operator, this will return me false. Is not will return true, guys. Is not will return true. Then let us focus on byte-array object. What do we have? We have a tuple object. A tuple object T1 got created, and this T1 I am passing to byte array. Okay, so that the conversion will be done, and this will create me a byte array object. This will create me a byte array object, and this byte array object will be stored in BA1. Done. Again, I am passing the same tuple object to one more. I am passing it to the same byte array function and storing the output to one more BA2 variable. So what do you think? Will BA1 and BA2 address will be same in the memory? Will address of BA1 and BA2 will be same? At least go for a guess. Instead of sitting silent, if you guess, you concentrate. The addresses will be different. Good. See, it will not point to the same address. Two different objects will be created. So when I use is operator, it will return me false. Is not will return me true. Okay. So this is about byte array. Let me do the same use on bytes object. I took a tuple object and I'm converting this to bytes. A bytes object is what it creates and stores in B1. Same. It also creates one more bytes object B2. Right? So will the address be same of B1 and B2? Again, no. The answer is no. It creates two different objects in the memory. They point to two different locations. So when I say is operator, it returns false. Is not will return true. You can ask me a question. Why are checking for each and every type of object individually? What is the reason behind it? Might be a question. Right? Now you'll understand it. Now you'll understand it. What am I doing in 1273? Line number 1273. Yes. So we are coming up with str object because we have Python sequence of characters enclosed in quotation marks. So this is an str object storing in S1. Same object, same value Python. Okay, the same case, I'm using the same case, I'm storing in different object S2. Now, tell me guys, will these objects S1 and S2, do they point to the same address in the memory or different address in the memory? In case of str objects, str data type, okay, do these objects S1 and S2, does they point to the same address or different address in the memory? Come on guys, make it fast. Okay. Yes. Here comes the answer and I want you guys to observe carefully. So I'm printing the address of S1 and I'm also printing the address of S2. What do you observe? S1 and S2 address is different or same? It is no more different. It is same. It is same. So what does it mean? That means, especially in the case of str data type, okay, if you are working on str objects, they will be stored to the same location, right? If the value is same, the objects will be pointing to the same value in the address. So that is why both S1 and S2 have same address. The location is seen. Yes. So I'm coming up with one more value. It is Python, which is in lowercase. But do you think S3 also will have the same address? No. S3 will have different address. Why? Because the Python that we have in uppercase and Python we have in lowercase, both are not seen. But these are seen because both of them are in uppercase. But this is in lowercase. So S3 address will be different. That is for sure. So when I say S1 is S2, the output will be true. The output will be true. S1 is not S2. The output will be false. Because S1 and S2 have same address, same location. Right? Then S1 is not S3. Yes, S1, S3 address are different. So obviously this is true. When I say S1 is S3, the output will be false. I hope you are understanding. You are getting the point. So far, even though if you have the same elements within the objects and if you are storing them to two different objects, they are created at different locations in the memory. But in case of str type, you observe that the objects are pointing to the same location in the memory, right? One more example. One more example in the case of str type. But what makes the difference between the previous and this one? I see this is very small. Okay. The sequence of characters that we have, the str object that we have in the previous case is very small. But this is a big one. Yes. What do you see here? Python is an OOPS language. Python is also functional programming language. Okay. Now tell me guys, will S1 and S2 store at same location? I mean, do they point to the same location or different location? Because they do contain the same characters. They do contain the same sequence of characters. Do they point to the same location or different location in the memory? What is your answer? What is your response? They point to different location. Good. See? Why so? I'll explain. The difference between, the previous example and this example is, the current example is, earlier these are called short string data. Okay, these are called short string data. Because of this, Python uses the same memory to store. No, it does not create a new object again because they are of short strings. But here it is a long string data. That is why S1 and S2, two different objects will be created at different locations. But in the previous case, it creates one object and the other object will be pointing to the same location. Why? It is of small string data. To save the memory, the internal memory, Python does it. Okay. So when I say S1 is S2, I'll get false. When I say S1 is not S2, I'll get true. Done. I'll make it fast. So in the next case, let me go with complex numbers, complex data type. 2 plus 3j I'm storing in A and the same complex number 2 plus 3j I'm storing in B. So do they point to the same location in the memory, both A and B? No, they don't point to the same location in the memory. They create Python creates two different objects. Two different objects will be created. When I say A is B, I'll get output as, false. When I say A is not B, I'll get the output as true. Yes. Let me go with bool values. B1 is equals to true, B2 is equals to true. Now tell me, do they point to the same location in the memory or different locations? Both B1 and B2. B1 and B2, do they point to the same location? Yes, they point to the same location. Why? Because true and false are singleton objects. They are singleton values. So that is why, even though if you assign these true, false values to n number of objects, n number of values, variables, all of these variables will be having the same location. They'll be sharing the same location. So when I use is operator, this will return me true and is not will return me false. Good. Let me go with the float value base. Float data type. A is equals to 3.4 and B is equals to 3.4. So does A and B share the location? Do they point to the same location or different location? If one is true and another one is false, obviously the location will change. See, here both of them are true. That is why the locations are same. If one is true and the other one is false, obviously the locations will change. They will vary. Got it? Yes. So in case of float type, again, Python creates two different objects, guys. The address will not be same. It creates two different objects. Okay. When I say A is B, it returns me false. When I say A is not B, it returns me true. And finally, int type. A is equals to 100, B is equals to 100. A is equals to 100 and B is equals to 100. What do you think? Do they point to the same location or different location in the memory, both A and B? Because the int value is same, the integer is same, 100. 100 is what we are storing in both A and B. So do they point to the same location or different location in the memory? No. Observe. They point to the same location. They point to the same location. If you observe, address of A and address of B is same. It is same. So, when I say A is B, it returns me true. When I say A is not B, it returns me false. So, what is your conclusion from here? So, that means integers. When you are storing integers in these variables in the back, in the objects, if the same variable is what we are storing in two different objects, two different variables, they are sharing their address. Both A and B are pointing to the same address in the memory. That is why you see the same location. Oh, isn't it? Yes. What if I take one more example? A is equals to minus, 257. In this case, will it be same? A wild guess. What will be the output here? Will they point to the same location or different location? A and B. They point to different locations, guys. They point to different locations. Hold on. In case of 100, both A and B are pointing to the same location. Why in case of 257, they are pointing to different location? Might be your question, right? Yes, I'll answer your question. Probably in the next 1-2 minutes, okay? When I say A is B, it returns me false. And if I say A is not B, it returns me true. The answer for your question is, especially in integers. When you are storing integers, we know that int type will be used. Int data type is used. So, in case of integers, between the values from -5 to 256, between the integers from -5 to 256, these integers are treated as small integers, and Python, uses the memory in order to reduce the memory usage. It will not create the objects again and again. That is what it has happened here. So both A and B are pointing to the same location in the memory. But if you go beyond that range, in the sense -5 to 256, if you go beyond that range, where I have to 257, there Python will create different objects. A will be a different object, B will be a different object in the memory. Let me try with taking a negative value also, negative integer. A is equals to -2, B is equals to -2. But if you observe here, both A and B are pointing to the same address, guys. They point to the same address in the memory. That is what we have discussed, right? Integers between -5 to 256. They are considered as small integers, and Python does not create different objects. I mean, different locations, different addresses will not be created. Whatever the variable that is going to store these numbers, these integers, the address will be shared. They'll be pointing to the same address. See, when I say A is B, it will return me true. When I say A is not B, it returns me false. What if I go beyond it, like -6? Here it will return me at different locations. Both A and B will be at different locations in the memory. I hope it is clear. So when I say A is B, this will return me false. And when I say A is not B, this will return me true. So this is all about identity operators. Identity operators, the purpose is, to check the address of the objects. Okay, whether the address, it helps us to compare the address of the objects, the variables. Within the identity operators, we have is and is not. Okay, so we have experimented for all the different objects we have in Python. We are done with it. So let us start the last operators. They are bitwise operators. They are bitwise operators. So for that, we'll understand the purpose of bitwise operators, then we'll come back. So what is the purpose of bitwise operators in Python? Purpose of bitwise operators is they help us to perform bitwise calculations. Bitwise calculations. Where these bitwise calculations are performed only on integer values, integer data, but not on float values or float data. Okay, so especially if you want to do it on float data, it will not accept. So even though if you are actually passing the integer data, integer number. This integer number will be converted to binary format. What does binary format means? Zeros and ones. Zeros and ones. Post converting the integer value to binary format, then it starts performing the calculation bit by bit. That is why it is called as bitwise operators. That is why they are named as bitwise operators. So what are the different types of bitwise operators that we have in Python are? There are in total 6 different types of bitwise operators. The first one is bitwise left shift operator. Second one is bitwise right shift operator. Third is bitwise OR operator. Fourth is bitwise AND operator. Fifth is bitwise complement operator. And the final one is bitwise XOR operator, XOR. And we also have the symbols. These are the respective symbols that we use for the bitwise operators. So we'll be understanding one by one, starting from bitwise left shift operator till bitwise XOR operator. They are very simple, guys. Okay. So why they are named as bitwise operators? Because they they perform the calculations bit by bit. See, even though if you pass int value an integer, this integer will be converted to zeros and ones. That means from decimal format to the number gets converted to binary format. Then the bit by bit calculations will be performed. And again, this binary format number will be converted back to decimal format. And then it returns the output. So this is what happens internally. Okay, you'll observe it, right? We are not going to do any conversion. Everything will be done by the bitwise operator only. Okay, so I'll start with bitwise left shift operator. Focus. So what do you mean by bitwise left shift operator? Here we have an image which is pictorially representing the bitwise left shift operator. How do we represent bitwise left shift operator? With less than symbol. Double less than symbol represents bitwise left shift operator. And what is the purpose of bitwise left shift operator? You know, it actually shifts the bits to the left side. Okay, we have right side and left side. So towards the left side, the bits will be shifted depending on the number of places we fix. Okay, here is a small example. I'll explain you how bitwise left shift operator works. Assume that I took a number 10. Okay, I took a number 10 and I'm storing in A. So this is what we keep in the Python. So when I use it in the Python, if I want to store 10 in A, this is what I do. Yes, but internally, if I use a 16-bit computer, if I'm using a 16-bit system, how 10 will be stored, you know, in this fashion. In this fashion, 10 gets stored. This 10, first of all, will be converted to binary format. How? You remember LCM? Yes. So the same process. So we use 2 for dividing 10. So we know 2 5s are 10. The output is 0. The remainder is 0. Again, 2 comes into the picture. 2 2s are 4. The remainder is 1. Because 5 minus 4 is 1. Again, if I go with 2, 2 1s are 2. The remainder is 0. So that's all. If I go in this direction, this will be my binary representation of binary format representation of 10. So that means 10, which is in decimal format, will be represented as 1010 in binary format. You see here, that is how 10 is represented. 10 gets stored in a 16-bit system. If you open your system, okay, in the settings, you will find the number of bits your system supports. Okay, So accordingly, the numbers that we are trying to store will be stored. This is the representation of 16-bit system. Okay, so you have 4 different blocks. In the last block, are 1 0. 1 0 gets stored. So this 1 0 1 0 is nothing but 10, guys. In decimal format system, it is 10. In binary format, 10 is represented as 1 0 1 0. Again, you may get a question, why we are dividing with 2 only? Because we are converting the decimal format number to binary format. Yes. In binary format number, how many different digits we have? Only zeros and ones. Only zeros and ones. Since we have 2 digits, we are dividing with 2. In decimal format, you'll have 10 digits. You'll have 10 digits. Right? From 0 to 9. Decimal format system, decimal number system is understood by humans. Binary number system is understandable by computers. Right? So what am I doing is, when I use this bitwise left shift operator, and if I specify the number of bits towards which this A has to be shifted. Okay, if I represent it with the number, I kept it as to 3 positions, A have to be shifted towards left side. So this number starts shifting towards the left side. This is left side. Yes. So it shifts to the left side. So when this shifts to the left side, this place will be occupied by 1. Yes. So this will be 0 and this will be coming here. Because only 3 places, right? So this will be here. This 0 comes to the next position for 1. And 1 will be coming to the next position 0. And this will be 0. This will be 0. This will be 0. This will be 0. So this is my, output of bitwise left shift operator. But what do you have? What do I have? The number is 1 0 1 0 0 0 and 0. One more 0. So this is the number that I have in binary format system. But this should be converted back to decimal format system. How can you convert it back to decimal format system? You reverse it. Okay. We use 2 power n formula. In a sense, this value, whatever the 0 will be multiplied with 2 power 0. Here you are dividing with 2, but when you are converting back, you have to take the power rule. Okay, plus 0 multiplied by 2 power 1 plus 0 multiplied by 2 power 2. How am I getting 0? This 0 here. The next 0 I am getting here. The next one here. In this way, I have to add all the values. Again, 0 multiplied by 2 power 3 plus 1 multiplied by 2 power 4 plus 0 multiplied by 2 power 5 plus finally 1 multiplied by 2 power 6. We know 0 multiplied by any number will be 0. So this is 0, this is 0, this is 0, this is 0, and this is also 0. The only 2 portions that I have to add is, this will be 16 and the other one will be, what is 2 power 6? 2 power 6 is 64, guys. 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64. When you add both, you'll get the output as 80. So this is how bitwise left shift operator works. Shifting the number of bits towards the left side. So the entire calculations converting to binary number, and then this binary number will be shifted towards the specified positions, and then once the output you get in the binary format, this will be converted back to the decimal format, So all these calculations will be done by your system. Internally, all these calculations will be done and directly you'll get the output. That's it. So this is all about bitwise left shift operator. Let me take an example. Okay. So I'll go back to Spider. If you see here, what am I doing? The same example is what you have here. A is equals to 10. Yes. A is equals to 10 is what you see here. Then, what am I doing? I am shifting this A, nothing but 10, to 3 positions. How many positions? 3 places. Okay. Towards the left side. Left shift operator, right? Towards the left side. That result is what I am storing in RES. So RES will be 80. See. So when I perform bitwise left shift operator on 10, by how many positions? By moving it to 3 positions, I'll get the output as 80. The output for my question will be 80. Whatever you have understood so far with respect to bitwise left shift operator, the same happens in bitwise right shift operator, but quite opposite. Right shift operator, right? So the bit starts moving towards the right hand side. So this side. Okay. So when you go in this side, obviously the bit starts going out. One out of it. Okay. So when it goes out, I'm taking the same example. Here I took left shift operator and here I'm going with right shift operator. Okay. So when I do it on the right hand side, I go back to the image for better understanding. So what happens? This is 10 represented in binary format. So I have to move it to the right hand side. Why? I'm applying right shift operator, right? When I start applying right shift operator, the bits start going outside of it. How many positions? To 3 bits. So 0 comes out, 1 comes out, and 0 also comes out. What do you have at the last position? The last position will be with 1. This 1 you'll have it here. But forward, all over the forward, the values will be 0. All of them will be 0. 0 doesn't matter. Now, this value, you convert it back to decimal format. When you convert it back to decimal format, 1 multiplied by 2 power 0, which is nothing but 1. 2 power anything power 0 is 1, guys. 1 multiplied 1 is 1. So, when I perform right shift operator on 10, when I perform right shift operator on 10 to 3 places, to 3 bits, the output will be 1. The output will be 1. So this is how the bitwise right shift operator works. Left shift operator pushes the bits towards the left hand side. Right shift operators, pushes the bits towards right hand side. So the output for the example should be 1, guys. Let us cross verify whether we are getting 1 or not. It will return 1. For sure it will return 1. See. You take any example, you can do it practically. Okay. When you do it, you'll understand. But first of all, you have to be clear with the conversions. How we are able to convert a decimal format number system to binary format. Then the binary format converting back to decimal format, it should be clear. Next to it, we have bitwise OR operator. Bitwise OR operator has a truth table. Okay. So this truth table is again similar to our logical operator OR. But instead of true and false, since we are working on bits, Under the bitwise OR operator, you will find only zeros and ones because these are bits. So when does bitwise OR operator return 1 is when both the values, when both the values are 0, only then the OR operator, bitwise OR operator returns 0. In rest of all the cases, it is returning 1 if you observe. Under logical OR, we understood if at least if one of the expression is true, OR operator returns true. In the same way, bitwise OR operator returns 1 if at least one of the bit is 1. Okay, if you see here, I have A is equals to 4 and B is equals to 5. Okay, when I store 4 in A and 5 in B, internally, 4 and 5 will be stored in this format, bits, zeros and ones. Now, if I apply A bitwise or B, what will be the output? You compare the corresponding bits and tell me the output in bitwise. I mean the binary system. That's okay. We'll do the conversion. Come on, guys. See, 100 represents what? This is not 100. It is actually 100, which is representing 4. 101 represents 5. Right? So, when I perform OR operator, if I have both of them 1, the output will be 1. Both of them 0, the output will be 0. Both the bits. 1 is 0, 1 is 1. Obviously 1. So, what will be the output? It is nothing but 101, which is in binary format. What is 101 in decimal format? It is obviously 5, right? So the answer is 5. The answer is 5. Simple. Let us not complicate it. See, I use this truth table to get this output. And once after I get the output in binary format, I'll do the conversion. Okay. What does the truth table says? If at least one of the bit is 1, the output will be 1. So let me execute whether I am getting 5 or not. For C, is the output, the final output is 5? Yes, it is 5. You're getting the point, guys? Right? In the same way, we have bitwise AND operator, which is represented with the symbol ampersand. When does bitwise AND operator return true? Bitwise AND operator, returns 1 only if both the bits are 1. Only if both the bits are 1, the output will be 1. In rest of the cases, the output will be 0. So the same example I am taking for easy understanding. I am taking the same example. 100,101. Let us apply AND operator, bitwise AND operator on these two values. 100, 100 and 101. So obviously this will be 0. This will also be 0, but here it will be 1. So what will be the output if I apply bitwise AND operator on 4 and 5? What will be the output? Exactly. This is 4, right? 100. 100 is 100. 100 is 4. Right? So let me execute. So A, then B, applying bitwise AND operator on both A and B. C will hold, the value 4. Perfect, guys. Good. Then, next to bitwise AND operator, we have bitwise complement operator. So this is the kind of NOT operator that we have under logical. Logical operators, we have NOT operator, which is performing the negation. Right? So we have bitwise complement operator. What does this complement operator is? We represent the complement operator in bitwise operators with negation. This is called tilde. Tilde. Okay. So this tilde will written as the complement of the given value. So we have a formula for it. If you memorize this formula, we are done. When you are applying the bitwise complement operator on any of the number, say if it is 100, the output will be minus of 100 plus 1. That means minus 101. That's it. So just memorize this formula so that you can answer the questions for bitwise complement operator. See here I'm applying bitwise complement operator on 10. What will be the output, guys? What will be the output for line number 1398? Tilde A. What is tilde? Tilde means bitwise complement operator. It means bitwise complement operator. So the output will be minus of 10 plus 1. It will be minus 11, not 11, minus 11. Okay. What if I apply it on minus 5? So it will be minus of minus 5 plus 1, which will be 4. Because minus 5 plus 4 plus 1 is minus 4. Minus of minus 4 is 4. Okay, focus. So this is the formula that you have to memorize for complement operator. Bitwise complement operator. Okay, so let me execute. We need not do anything, but in interviews, you may get questions, right? So that is the reason you are supposed to memorize these formulas. Done. And finally, bitwise XOR operator, which is represented with the cap symbol. What exactly this XOR represent is exclusively OR operator. Exclusively OR operator. So we have a truth table for XOR operator as well. Okay. So when does this XOR operator returns 1? Is when both the bits are opposite. See, when both the bits are 0, 1 and 1, 0, the output is 1. The output is 1. What if they are same? If they are same, the output is 0. That is how exclusively OR operator, bitwise exclusively OR operator works. So if you see here, we know 4 in binary format is written as 100. 5 is written as 101. 101. Now, if I apply exclusively OR operator between 4 and 5, what will be the output, guys? Tell me what will be the output? So they are different, 0, 1. Both the bits are different. If they are different, the output is 1. If they are same, the output is 0. Same, 0. So this is the output that we have in this, binary format, 0, 0, 1. You convert this into decimal format. When you convert it into decimal format, you'll get the output also in 1. The output will also be 1. Why? 1 into 2 power 0 is nothing but 1. So let me execute. A equals to 4, B equals to 5, and A exclusively OR operator, bitwise exclusively OR operator B will be returning me C value as 1. So let me print the C value. It is 1. Good. Perfect. Right. So with this, we have successfully completed the operators topic in Python. Okay. I want you guys to practice. See, when you do multiple examples, when you take multiple examples and when you do hands-on practice, you'll be memorizing for long time days. Okay. So Python is easy when you do practice. So I thought actually we can also learn conditional statements, but we are unable to do it. We'll do it on the next day. That's okay. In the next session, we'll be understanding the conditional statements and followed by, we also have loops, the purpose of loops and the types of loops, followed by break control statements, flow control statements we have like break, continue, and pass. Then next to that, we have functions. So we'll be understanding all these topics in the next week because we are actually the end of this weekend. So I hope we had a great session today, right? And even if you felt the same, do hit on the like button, guys. Encourage us as we are coming up with n number of programs in future, right? So when you encourage us, we will be having a thought like we are supposed to do more programs. So do support us by hitting on the like button, and if you have any kind of questions, yes, feel free to ask your questions. Okay, your doubts will be resolved. It might be technical or non-technical. Don't hesitate in asking your questions. And also share across your connections. Do share across your connections. Ask them to learn Python. See, the stuff that we are coming up here is, I don't believe you will not have this stuff anywhere on the planet. Until unless if you go to the official site of Python, right? So ask your connections. So whoever is looking out to learn Python, if they want to learn Python, do support our channel by sharing our channel to your colleagues, your team members, whomever it might be. Right. So it's time for our questions. Any questions? I hope all went well because I'm actually slow. And I hope we have covered each and every point with respect to operators. Okay. So the only topic, the only part that is pending is practice. When you do hands-on, for sure you'll memorize. Thank you. Thanks for your feedback. And even in the feedback link, do post, give your genuine feedback. Okay. See, it's very simple. Is and is not operated. It is part of identity operators. Okay. So what exactly does these identity operators does is, identity operators, they help us to compare the memory address. See, when you are storing any object, when you want to store a value in an object, what happens? This value, for example, I want to store 10 in A. Okay. We use the assignment operator and we are able to assign it. This is what we are learning, right? But in the back end, where is this value getting stored? Where is this 10 getting stored? Is in the memory, in the main memory, right? So within the Python's memory, what exactly happens is the objects, the variables will have some address. They will have some address or location. Okay. So the identity operators, they compare these address values with what address? The address of the objects in the memory. Okay. If I have two objects, two variables like A and B, I want to check whether they both A and B, are they at the same memory address? Are they sharing the address or they are at different address locations? So that can be compared using identity operators. And we have two identity operators. One is and the other one is not. When does is operator return true? when both the objects share the same address. When they point to the same address, is operator will return true. Okay. What if these both objects are pointing to different address? Okay. Then is operator returns false. Right. In the same way, is not works quite opposite to is. So this is all about identity operators. And what you have to memorize, the important points are, especially in the case of bool values, that means true, false, or int values, integers between the range of -5 to 256. Then str type values, str objects, if they are small, I'll keep it here small, and none, which is a singleton object. Okay. So even only in these cases, the address will be seen. Both the objects, right, whatever, not only both, it can be n number of objects. Okay. If assume that I am storing true in 5 different objects, go and check the address of all these 5 objects, 5 variables. It will point to the same memory address. The address will be same for all the 5 variables or objects. So these are important. You take any other examples, in any other cases, the address will be different. Because Python creates different objects. But only in this case, the address will be same for the objects. I have specified, right? I have clearly specified. Yeah. So this is very important. And in general, I don't believe this point is shared in any of the videos sessions, but we are actually doing a lot of research and we are coming up with the content. Okay. So that is why we want you guys to encourage us. When you encourage us, for sure, we are going to plan n number of wonderful sessions. In future, we are coming up with more sessions related to AI. When you can build AI is, an AI application is, when you are good at Python. Only if you are good at Python basics, fundamental topics, yes, you can come up with a ML application, you can build an AI application, you can build a Gen AI application, agentic AI, whatnot. But what is your core point is Python. Because Python is the language that is used for building the logic. If you don't understand Python itself, what is the purpose of directly going and building an application of AI? I hope you are getting the point, guys. Okay, so that's all for the day. And still, if you have any kind of questions, just feel free to ask your questions. For commerce and management, soon, domain based, we haven't planned, but we'll be planning it as well. A particular, part, yes, we did not plan it so far, but we'll do it. Right? Any other questions? That symbol is called tilde. Can we have session on advanced? Yeah, we'll be informing you prior at least 10-15 days. Okay. So we'll be sharing whatever the sessions that we are going to come up with at least 2 to 3 weeks prior. No worries, we'll be coming up with all the sessions. The only thing that we need from you is support. When you support people like us, we'll be coming up with amazing sessions in the future. Right? How can you support is by sharing our channel to your, connections. See, whoever has a need of learning a particular topic, yes, do refer our channel because we are coming up with, the amazing content, right? Where you can learn more, lot of things. Yeah, we'll be doing all the sessions related to AI, but time. Okay. So we have planned, we have scheduled it. We'll be doing it soon. Thank you. Thank you for your feedback.